our fifth video of concave mirrors and the images they form. We are going to have a quiz on Wednesday, so be sure that you're reviewing all of these and make sure you can solve problems using the mirror equation and the magnification equation. In the previous four videos, we've talked about images formed by concave mirrors when the object is way out here, past the center of curvature, at the center of curvature, and then in the last video, in front of the center of curvature. And the question I asked at the end of the last video was to predict. I asked you to predict what's going to happen when this object gets closer and closer and then eventually is at the focal point. Of course, right now I have the object at 6, so DO is 6. You can see that down here. And the focal length for this mirror has always been 4. So it's getting there, but it's not quite there. So what I'll remind you that we saw last time is that once the object is between the center of curvature and the focus, the image is larger than the object. Of course, it's inverted. That's what that negative sign means. The image is larger than the object, and the image distance is greater than the object distance. And if we continue to keep the object the same size, but move it closer and closer, you can see that the image now is so far away, we can't even see it on this screen here. The space provided by this simulation does not allow us to see it. It was visible, and now it's not. And what you might notice is happening is the point right here, this point, where the reflected light rays intersect, continues to move farther and farther and farther away from the mirror. And that's why the image moves farther from the mirror. At this point, the image distance is 12. At this point, the image distance is 20. At this point, the image distance is more than 30. But watch what happens when I place the object precisely at the focal point. Look at that. You can see it says right over here, no image. And it even explains why there's no image. Parallel rays, it says. In other words, the light rays from the object reflect off the mirror parallel to each other. The way they reflect off the mirror causes them to reflect parallel to each other. And we know, of course, that parallel light rays never intersect. So the answer to the question, where will the image be formed, is also the answer to the question, where will the reflected light rays intersect? And the answer, of course, when they're parallel is they will never intersect. So again, if we're a little bit farther away, you can see that there is some point where they will intersect. But if we are precisely at the focal point, there is no point where reflected light rays intersect. In fact, the light rays are parallel and they do not intersect. So we say that there is no image. Now, the last thing I'd like you to think about before I record and post the 6th video is what's going to happen now as this object gets in front of the focal point, gets closer to the mirror than the focal point. We've seen what happens out past the center of curvature, at the center of curvature, between the center and the focus, at the focus. Now there's one more area we need to cover, and what's going to happen when the object is in here. See if you can predict that before I show it to you.